Hello everyone and welcome to today's exciting webinar on battery management system or BMS for short. So BMS is at the heart of the transition to cleaner, more sustainable energy solutions, and it is playing a pivotal role in optimizing the performance, safety and longevity of the energy storage systems and electric vehicles. In this webinar, we'll delve into the intricacies of BMS and discuss the future enhancements and the impact that it is bringing in energy storage solutions. So clearly, we have an exciting session ahead of us, and we are honored to have a distinguished expert with us. That's Mr. Mukesh Kumar Bansal, the CTO at TelioEV. He's a true enthusiast in the field of electric vehicles and BMS. Glad to have you with us, sir.
Thank you, Aditya, for introducing. I'm excited here to share my experience on the BMS or whatever knowledge I have, right?
Certainly, sir. So let's get right into it, sir. So to start with, it would be great if you can tell our viewers what a BMS is and why is it important for a battery-powered application?
Yeah. So we already know batteries from long years, right? Everywhere, maybe in our day-to-day life, we are seeing a lot of products which are battery operated, correct? So we see in inverters at home, we see in electric vehicles now a buzzword, right? Or a new era of transportation where battery is the key component, correct? So if we see the existing batteries used in home, they are lead acid gel batteries or maybe traditional batteries. So no electronics is there. But when we talk about the batteries in electric vehicle, right? So those are a different chemistry of batteries. So where those are entirely different from the batteries we used in inverters, we used in normal cars for traction batteries, right? So here these batteries are consist of different cells made of cells where series and parallel combinations of individual cell is made, right? To manage those cell individual voltages, balance those cells. So electronic circuitry is used, which is called battery management system. So why it is crucial? Because it helps managing the cell balancing, managing the temperature of the individual cells, then extend the life of battery, right? And optimizing the charging cycles. So that way, BMS is very crucial component of any battery, which is used in electric vehicle. Or maybe another
Okay.
application, which is consist of different cells.
Okay. Thank you for answering that one, sir. And you started talking about it, but let's get deeper into it. So, what would be the primary functions of a BMS beyond just monitoring the battery state?
Yeah, so BMS is like having many functionalities, and those are very important in case of lithium-ion batteries, lithium ferrophosphate batteries, or any batteries used in electric vehicle, apart from lead acid and gel, right? And the first most important is cell balancing, because these are like multiple cells of 2.8 volt, 2.3 volt, depends on the battery chemistry. And the battery packs are made of high voltage, say 92 volt, then 400 volt, or maybe it depends upon the capacity of the battery and the type of vehicle, right? And when we charge these batteries, we make these batteries with series and parallel combination. It is very important to balance each and individual cells and strings, basically, which are connected in parallel, right?
Okay.
So if any of the string is imbalanced, so output voltage of the battery will be on toss. So that way, one of the most critical functionality of BMS is cell balancing. And another most important is temperature management. All these cells, when they get charged, a lot of heat is produced, right? And because these are very high current is drawn from the batteries, they are charged with high current with the fast chargers. So a lot of heat is there. To avoid the overheating functionality, to avoid the thermal runaway for the safety, right? It plays a crucial role, right? Then another important role is managing the SOC, measuring the SOC basically, which is state of the charge, how much battery is there, when to stop the charging, when to give the warnings, right? When to trip based on safety limits of the battery capacity, right? Then current management. Then another thing is like error detection and reporting. because these BMSs are not dumb electronics. They goes with lot of softwares inside that, right? Which keep on measuring the conditions of multiple conditions based on the safety. Then they can communicate to the outer world also. Yeah.
Okay. So basically, BMS is controlling everything. It's
Yeah.
stopping the battery from exploding also.
Yeah.
Huh?
True.
Okay. And so while we have discussed what a BMS is, what would be the key challenges in a BMS that it would help address? In the sense, like, well, maybe you could speak more about it.
Yeah, so there are a lot of key challenges and critical parameters which need to be taken care when or need to address while designing a BMS or designing a battery. Right? The foremost is the battery chemistry, the first critical parameter, because every chemistry is having a different cell voltage levels, right? And they have different charging profiles also. So BMS makes sure that when you are charging the battery, it complies to all the charging profile, right? It stops when it need to stop. It whatever current it needs for charging, controlling the current. When even though based on temperature, controlling the current, right? And even though some of the chemistries they are very sensitive to temperature, basically operating environment. So when temperature batteries charge at extreme cold or extreme heat areas, right? So different behavior of charging is there. So BMH
Mhm.
help there to optimize the charging profile based on the temperature condition, operating environmental conditions, right? And another important part is battery degradation. So when battery degrade, if you see, uh, it's any chemistry, when aging happens, based on the age, the battery get degrade over the time, right? So the performance also decreases. So the BMS is needed to adopt to the charging characteristics of the battery pack based on the aging, right? So that whenever its battery is used after aging, at least it gives a optimal performance and safety. Yeah.
I actually had a question on how BMS is optimizing the battery life and performance, but I think you've already answered that one.
Mhm.
Okay. And moving on, what role does communication play in a BMS, and how does it enable real-time data and control?
Yeah. So as I already discussed, like BMS is not a dumb electronics, right? A lot of software goes into that, right? And communication is one of the main part of BMS, because whenever any battery goes into electric vehicle, right? So that communicate with lot of another electronic control units installed in the vehicle, right? ECUs, which we called, right? And a lot of communication protocols are there, like CAN communication, then Modbus communication, uh, then power line communication. Lot of different communication modes are there. And why it is important? Because when we are putting any fast charger to charge the electric vehicle, right? Then the EV charger, the fast charger that directly interact with the BMS. There is no another onboard chargers comes into picture. So BMS communicate lot of information to the charger, like what is the state of the charge right now, what is the voltage level, current level, any safety or warning alerts are there or not, right? And the BMS also communicate with the ECUs like uh, battery performance related stuff. The data is also used by the vehicle to showcase what is the levels of the battery, voltage levels on the instrument cluster of the vehicle, right? So communication
So
is
does it also help in giving the range estimation also?
yes. So this data is used in the infotainment systems, in the instrument clusters, where it estimates the uh, kilometers remaining based on the state of the charge available in the battery and based on the usage pattern of the driver, right? How it's they are rash driving, they are doing a normal driving, right? So based on that, this data which is coming from the BMS, it helps. And
Okay, so
another
there's even AI involved in this.
yes, AI is also there. And another important is like predictive maintenance. right? If you are getting data from the BMS, you can predict the life of the battery, you can predict the when maintenance is required for the battery pack, right? For the vehicle, a lot of things are clubbed on that.
Okay. So while you were talking about predictive maintenance,
Mhm.
how does predictive maintenance play a role in battery management, and how is a BMS enabling predictive maintenance?
Yeah, so predictive maintenance is very much required, right? As we are seeing, like we discussed about different parameters of battery, right? Life degradation, right? And then cell imbalancing, right? We talked about temperatures. We talked about overcurrent drawn or maybe fast charging, right? So predictive maintenance helps in managing the battery, and even though it also helps the owners to go to the service center and have a battery pack checked, right, before it get breakdown, right? So the communication helps here to get the data coming out from the battery, going and measurements of the current voltages, temperature, SOC, and the cell level voltage is also, string level voltage is also, which required for cell balancing.
Okay.
Yeah.
Okay, so thank you for answering this one. Moving on, while we were talking about batteries, what are the current policies and the standards for batteries and BMSs in India?
So, if you see, as battery is a crucial component for any of the electric vehicle. We have seen in the past, like a lot of incidents happen where people used non-standard BMSs, where people used recycled battery packs, right? And improper, without safety protection, they have used the battery packs in the vehicle, and we have seen a lot of mishappening happens. So a lot of standards helps here, homologation helps here, where government validate that the battery packs are now tested against those standards, and very stringent standards are there in India now. So few standards like AIS 038, it's a standard for vehicle safety. Then there is another standard came which is AIS 048, which is for battery safety, right? Then new
Mhm.
standard came, which is AES 038 revision 2 and AES 156 standard. So
Okay.
AES 156 standard is a altogether a club single standard which makes sure the battery safety and the vehicle safety. And it consider these standards are designed such a way that it considering all the parameters, be it a mechanical aspect, be it a safety hazards, be it electrical safety, be it fire safety, you name like water ingress test like IP protections, right? And dust protections. So a lot of things are considered into these standards, and they are also in line with the global standards like UN R100. United Nations standards are there, right? So they are also in
Okay.
line with the global standards for battery packs, and BMS is used into that, into the vehicles, for the vehicle and battery safety. Yeah.
Okay. Thank you for answering that one, sir. And so, while we have talked about current policies and standards, uh, can you please provide a few insights into the future of battery management system and how they are shaping various industries and technologies?
Yeah, so it's very good question, right? So as we are seeing, a lot of advancements are happening in battery chemistry, right? So there's a lot of scope in BMS also, because new chemistries will come. Definitely, new BMS compatible to those battery chemistries is required. So there is one area where a lot of innovation is coming, right? Earlier, the
Mhm.
BMSs were without any software. Now there's new standard like AIS 156 and all these standards, right? And the new standard which are in draft maybe, where it is mandatory to have a computing device on the BMS. Computing device means
Okay.
a lot of data it can capture, a lot of data it can analyze on the BMS itself, the safety protection it can initiate, right? And another future is like lot of AI and machine learning we are hearing, right? It is happening.
Mhm.
So BMS will definitely help here to provide all the required data for any machine learning model, right? Any artificial intelligence algorithms, right? Which can help in prediction or like predictive maintenance. One we already discussed. The second part, lot of new applications where, like, for example, insurance companies, they are working on the data based on the driver driving pattern, right? To design their premium policies.
Oh, is it?
Yeah. And for that, BMS is one of the critical component part of the whole end-to-end solution, because that needs how much current is drawn from the battery, how much current is going, its rash driving, how the battery is maintained, right? Because battery is the most costliest component. If we say it's one of the biggest cost in the vehicle, right? If and life is also there, like 8 year, 10 year life is there. So if any companies like who are giving battery warranty, right, battery manufacturer, definitely they need a lot of data, right?
Good.
And if any insurance company they are going to design an insurance, definitely they need a lot of data. So here BMS plays an important role, and lot of edge computing kind of thing we are expecting in BMS itself, right?
Okay.
It will help to drive these kind of new innovations, new applications, new business models, new data driven things, right? And there. And nowadays, BMSs are coming up with inbuilt connectivity like GSM, then GPS also, because battery packs
Yes.
are now we are having a swappable battery. So tracking is one of the most critical component area, right? If somebody stole the battery, he's not returning where my battery pack is. So a lot of communication is also going there. Yeah. So definitely we'll see new advancement, new innovations in BMS as industry is evolving, as batteries are evolving, and a lot of other areas like not only EV industry, the grid load management also. The battery
Mhm.
packs are also used to manage the load on the grid, peak load on the grid. So where
Okay.
BMS is very important. A renewable energy area where battery packs are used to store the energy from the sun in the day and the night time to utilize that, right? So in those areas also a lot of new applications people are working on.
Because it can be said that BMS is playing a very important role in the whole e-revolution.
Yes, yes, definitely. And all the storage industry where new chemistries are working because of the density, energy density. If you see the batteries which you have, maybe lead acid battery that is bigger in size, and if we compare the similar capacity of battery in lead acid, lithium ferrophosphate, or maybe lithium titanium oxide, they are smaller in size. This is because of the energy density is increasing, because of the new chemistries are coming, and to manage all these chemistries to make those safer, make more usable, obviously electronics and software will come into picture. So where BMS will play a role.
Certainly, sir. So, looks like that was the last question for today's webinar. A big thank you, sir, for being a esteemed guest today and sharing your expertise. Your insights have been truly enriching, and our understanding of battery management softwares have gone through the roof through this webinar. Thank you, sir.
You're welcome. Thanks a lot. Have a good day.
Yeah.
Bye.
Bye, sir.